Hi everybody, this is Mr. Bowman, and this is the first of several videos that I'm going to make for you to review a variety of AP Calculus topics. This first video is going to cover derivatives, maxes and mins, and inflection points. And we are also going to take a look at the mean value theorem. So our first question here is a no calculator free response question, and let's see what they tell us about this. Let f be the function defined by f of x is equal to cosine of 2x plus e to the sine x. Let g be a differentiable function. The table gives values of g and its derivative g prime at selected values of x. And let h be the function whose graph, consisting of 5 line segments, is shown in the figure above. The fact that g is differentiable allows us to conclude that g is continuous, and the fact that h consists of line segments allows us to find the slopes of those line segments if we want to. Part A says find the slope of the line tangent to the graph of f at x equal pi. That is a 2-point portion of that question. And literally to find that, we simply need to find f prime of x and evaluate it at x equal pi. So f prime of x is equal to, don't forget to apply the chain rule here, so negative sine of 2x times the derivative of 2x, which is 2, plus e to the sine of x times the derivative of the sine of x, which is the cosine of x. And then we need to evaluate that at pi. So we're going to jump over to the scoring rubric here, and on the scoring rubric here you can see our derivative. That's equivalent to what we found, and then you have to evaluate that at 2 pi. At pi, I'm sorry. And you cannot leave these unsimplified. You have to evaluate those trig functions there. So don't forget to do that. You also have to evaluate that one there. And that's where your 2 points come from in that first portion. The second part, part B, is also worth 2 points. And it says, let k be the function defined by k of x is equal to h of f of x. Find k prime of pi. So k prime of x is going to be equal to, using the chain rule again, h prime at f of x times f prime of x, the derivative of the outside evaluated at the inside, times the derivative of the inside. Now we need to plug in x equal pi and evaluate f of x and f prime of x, and then h prime of f of pi. So we jump over to the scoring rubric here. You get 1 point for finding the derivative, and the second point is for evaluating it at pi. So we plug pi into f, and we plug pi into f prime, and we read those from the table. F of pi is 2, f prime of pi is negative 1. Then we need to find h prime of 2. Well, if we go back and we look at h, we have a graph of h. We need to find the slope of the graph of h at x equal 2. So we can see that we have a rise of negative 1 and a run of 3. So negative 1, positive 3. So h prime of 2 is equal to negative 1/3. And that's where this negative 1/3 comes from right there, times f prime of pi, which is negative 1, and we have a final answer of 1/3. That's where the second point comes from on that free response question. Part C of this question is worth 3 points. Let m be the function defined by m of x equals g of negative 2x times h of x. Find m prime of 2. The first 2 points for that come from evaluating or finding m prime of x. So m prime of x is going to be equal to g prime of negative 2x times negative 2, because we're using the chain rule and the product rule here at the same time, times h of x, so the derivative of the first times the second, plus the first, g of negative 2x, times the derivative of the second, h prime of x. So the chain rule and the product rule thrown together there, and that gives you 2 points, and you're going to get 1 point for the first part and 1 point for the second part. The third point, is you have to find the derivative of m prime, or you have to find m prime at 2. So you need to plug 2 in everywhere for x. So you're going to have g prime of negative 4 times negative 2 times h of 2 plus g of negative 4 times h prime of 2. And g and g prime values are going to come from the table above. H prime of 2 you actually found earlier because you needed it for part B, and h of 2 you're going to read off the table. Now be careful about h of 2 because h of 2 is the y coordinate of that point, and since there's a slope of negative 1/3 and x is 2, this y coordinate is going to be equal to negative 2/3. So let's jump over to the scoring rubric here and find all of these. So we have negative 2 times g prime of negative 4 from the table, which is negative 1. H of 2 we just found is negative 2/3. G of negative 4 from the table is 5. H prime of 2 we found in the previous part B, which is negative 1/3. And you can leave it like that, or you can simplify it if you want, but those are your 3 points. And the last part, part D, is going to be worth 2 points because all free response questions are worth 9 points total. And D asks, is there a number C in the closed interval from negative 5 to negative 3 such that g prime of C is equal to negative 4? Justify your answer. Well, g prime of C is the instantaneous rate of change of g at some x value. And is there a place where that is going to be equal to negative 4 on the closed interval from negative 5 to negative 3? Well, g is differentiable. Therefore, g is also continuous. So the answer to that question lies in the following. G prime of C should be equal to the average rate of change over that interval because we meet the conditions for the mean value theorem. So we need to evaluate g of negative 3 minus g of negative 5 over negative 3 minus negative 5. So basically we're finding the slope of the secant line and figuring out what that is. So again, from the table we can find those values, and if we look at the scoring rubric, g of negative 3 is equal to 2, g of negative 5 is equal to 10, and negative 3 minus negative 5 is positive 2. So you simplify that and you get a average rate of change of negative 4. Again, because we were told in the stem of the problem that g is differentiable, that means g is differentiable and continuous on this closed interval, and therefore the mean value theorem applies, and therefore the instantaneous rate of change will be equal to the average rate of change for at least one value between -5 and -3. And to get full credit there, you need to show the work to find the average rate of change, and then you need to justify that by invoking the mean value theorem. And remember, the mean value theorem says that the average rate of change will be equal to the instantaneous rate of change for some x value, at least once, for some x value between the endpoints of the interval if the function is continuous on the closed interval and differentiable on the open interval. In this second problem, it is also a no calculator problem. We are given the graph of f prime. The figure above shows the graph of f prime, the derivative of a twice differentiable function f on the interval from -3 to +4. The graph of f prime has horizontal tangents at x equal -1, horizontal tangent at x equal -1, x equal 1, and x equal 3. So the derivative of f prime is equal to 0 at those places. The areas of the region bounded by the x-axis and the graph of f prime on the intervals from -2 to 1 and 1 to 4 are 9 and 12 respectively. So this area is 9 and this area is 12. First part of this asks to find all x coordinates at which f has a relative maximum. Give a reason for your answer. Alright, so let's start at the left endpoint where x is equal to -3 and see if we can find all the places where f has a relative maximum. Since we are including the endpoints, we have to think about f prime, or whether or not f is increasing to the right or left of those endpoints. So at x equal -3, or to the right of x equal -3, f prime is positive, which means f is increasing, which means f has a minimum at x equal -3. At x equal -2, f prime changes from positive to negative, which means that f goes from increasing to decreasing, so x equal -2 is definitely one place where f has a local maximum. At x equal 1, f prime goes from negative to 0 to negative again, so f is decreasing, remains constant momentarily at x equal 1 because its derivative, f prime, is 0 there, and then continues to decrease again, and continues decreasing until x is equal to 4, which would mean that x equal to 4 is a local minimum as well, and that's all we have. So our answer is x equal -2, and we have to provide a justification for that. So f prime of x changes from positive to negative at x equal -2, therefore f has a relative maximum at x equal 2. That first part is worth 2 points, one for the answer and one for the justification. Part B asks, on what open intervals contained in the interval from -3 to 4 is the graph of f both concave down and decreasing? So to be concave down, f double prime has to be negative, and for f to be decreasing, f prime has to be negative as well. So f double prime is the slope of f prime. So effectively what we're saying is f prime has to be decreasing and f prime has to be negative for f to be concave down and decreasing. Where does that happen? That happens from -2 to -1 because we're using open intervals, and from 1 to 3. If we jump over here to the scoring rubric, this is also worth 2 points. The graph of f is concave down and decreasing on the intervals -2 to -1, 1 to 3, because f prime is decreasing and negative. Notice they write everything in terms of f prime, which is what they have a graph of. So the first 2 parts worth 2 points apiece. The third part also worth 2 points. It says, find the x-coordinates of all points of inflection for the graph of f. Give a reason for your answer. Inflection points are where the second derivative of a function changes sign. So for the graph of f, we need f double prime to change sign, changes sign. But we do not have a graph of f double prime. What we have a graph of is f prime. So f double prime changes signs when f prime changes from decreasing to increasing or increasing to decreasing. So that's going to take place at the x values of -1, +1, and +3, because those are the places where f prime changes from increasing or decreasing to increasing or increasing to decreasing. So if we take a look at the scoring on that, it has inflection points at x equal -1 and x equal 3, also at x equal 1. Why'd they separate them here? Because at -1, at x equal -1 and +3, because f prime changes from decreasing to increasing, at x equal 1, because f prime changes from increasing to decreasing. Again, we need to explain in terms of the information that we're given f prime, not f double prime. So you have to relate f double prime being positive or negative to whether or not f prime is increasing or decreasing. And the last part of this question is worth 3 points because we've got 6 accounted for already. And it says, given that f of 1 is equal to 3, write an expression for f of x that involves an integral. Find f of 4 and f of -2. All right, so let's think about what we have here. We have a graph of f prime, and we need to find an expression for f of x. Well, if we integrate f prime, we're going to have, let's say from a to b, f prime of t dt, we're going to have f of b minus f of a. Well, if we were to replace the upper limit with x, f prime of t dt, and the lower limit with 1, we would have the following. We would have f of x minus f of 3. And we were told, f of 1, and we were told that f of 1 is equal to 3. So if we solve this for f of x, we get f of x is equal to the integral from 1 to x of f prime of t dt plus f of 1, but f of 1 is equal to 3. So if we want to evaluate and find f of 4, we're going to integrate from 1 to 4 f prime of t dt. So f of 4 is going to be the integral from 1 to 4 of the graph above. And the integral from 1 to 4 is not positive 12, it's negative 12 because the area is below the x-axis. So our answer is going to be negative 12 plus 3 or negative 9. F of negative 2 is going to be the integral from 1 to negative 2 of f prime of t dt plus 3. Be careful, from 1 to negative 2 would be an integral of, well, the area is below the x-axis, but which would make that negative, but we're integrating backward, so we have to change the sign on that. So that integral would actually be 9, and 9 plus 3 is equal to 15. So you're going to get 3 points for that. One of them is going to be for this right here, one of them is going to be for that right there, and one of them is going to be for that right there. And I just realized a good example of why you may not want to simplify something. This is a stupid mistake that I made. 9 plus 3 is not 15, it is actually equal to 12.